what you don't know that this is actually take 3. I should probably stop for the day, but I'm just trying to get some things loaded for you guys this week so that you have something to work with. This is example 2 from our finding our shear and moment equations. It's different than the example 2 we did in the last set of problems, which was finding internal forces. I just want to work right now with straight beams and simplify our lives just a little bit. So what you need to do is, just like we've been doing, is find yourself a white piece of paper. And we're going to slowly move across my beam and figure out where we have loads that change. So what I need you guys to do right now is pause the video, and I want you to write down your 2 sections of beam. Oh, I just told you that we have 2 sections of beam. And I would like you to go ahead and draw that free body diagram from 0 to 6 feet while I get this labeled. Okay, shear has units of kips, moments has kip feet. So 0 to 6 feet. If you need to use a little piece of paper to cover up, I suggest you do that. We are going to cover everything to the right and just show things to the left from 0 to 6. We can see here that we have 8 kips from our reaction. We are going to have some sort of a load that looks like a triangle, but if I'm only going over a distance of x, I cannot call the peak of this triangle 4. For instance, if I only went over 3 feet, I can see that the peak would have 2 kips per feet. So how do I determine what the equation of this line is? Essentially, that's what we need to write. So we're going to go all the way back to 8th grade algebra. And the equation of a line is y equals mx plus b. If this is our x, as we're moving from left to right, and my y is going up, then we can clearly see we are crossing the y-axis at 0. And b is our y-intercept, and our y-intercept is at 0. The next thing we need to find is slope of the line. This is slope. Slope is rise over run. If I look at my complete triangle, if you want to call it that, I have a rise of 4 and a run of 6. So I have a slope of 2/3. So now I can go back and I can say y equals 2/3 x plus 0. Okay, that's the equation of my line. I also know, I'm going to move this x over, I also know that when I need to find that moment, that the moment arm is going to be x over 3, because as I'm moving along, the centroid of that triangle is going to remain at a 2/3, 1/3 ratio. So now that I have a nice little free body diagram drawn, I hope y'all have the same diagram, we can get started. We're going to sum our forces in the y direction. They have to equal 0. So I have 8 minus, well, I have a lot of functions and x's and equations, but I do know that my force is still going to be the area under the curve. My area of a triangle is 1/2. My base now is in terms of x, and my slope is 2/3 x. So I can find the area of that triangle as it pertains to x, the position we are down the length of the beam. Minus v, again, positive behavior, negative according to my convention of up is positive. So we get our shear equals, move the v over, and we get 8 minus, doink, doink, x squared over 3 kips. We can do the same thing, and we can sum moments about that cut. So I can see that that 8 kips has a moment arm of x. I can see this is causing positive right-hand rule rotation. Again, it's the area under the curve times the moment arm. So I have 1/2 base times height. That's my force. And then the moment arm is 1/3 x. That's my distance. Plus m equals 0. So my moment, move everything over, 8x minus, doink, doink, x cubed over 9 kip feet. Okay, that's the equation of our moment. So when we're in this segment of the beam, then we are going to have a shear of 8 minus x squared over 3. And we are going to have a moment of 8x minus x cubed over 9. Okay, some of you may be noticing a little bit of a pattern here. It really only works when we start at 0. So do you have to write the equations of equilibrium to come up with your equation for moment? Yes, you do. Okay, you have to show us. 6 to 12, new free body diagram. I want you guys to draw your free body diagram while I draw mine. And hopefully we have something that looks very, very similar. Normal, shear, moment. If this is x, this has to be x minus 6. And that means that the area is going to come back here at 2 meters, and we're going to make this 4 meters. So all of this is 6, but the point load is going to be 2 meters over. So if I want to sum forces in the y direction, again, I have 8 minus, well, what's the area under a curve? 1/2 base times height, 1/2 6 times 4, doink, doink, 12. So 12 kips minus 12 kips minus V equals 0. So my shear equals -4 kips. So it's a constant. It doesn't matter where I am between 6 and 12 feet. We are going to have -4 kips. Let's sum the moments about the cut. Here's our cut. So starting at the left, wait for it to come back into focus. Maybe. There we go. Starting at the left, going about our cut, we have 8 times, well, x is the full development of that moment arm, negative, plus 12 times its moment arm is going to be x minus 6 plus 2. You guys see that? I have to walk x minus 6 back to where that load begins, and then to the centroid is another 2 feet. Nothing else causes a moment. Then we have this positive moment equals 0. So when I do my algebra, I am going to get, I know that I said -8 times x, which is my moment arm, and yet I magically wrote an 8 because sometimes my brain does not communicate with my hand very well. So I have, we're going to move all these things over, 8x minus 12 times x minus 4 equals 0. No, it doesn't equal 0 anymore. I'm tired. Okay. Equals 8x minus 12x plus 48 equals minus 4x plus 48. And that is the equation for our moment. So when we're looking over here at this segment, we have v equals -4, and we have a moment of -4x plus 48. So now it's time to begin graphing. When x equals 0, I get that my shear equals 8. When x equals 6, I get that my shear equals, let's look and see. We have 36 squared, 3 divided by, change the sign, add it to 8, and I get -4. So my shear goes from a positive 8 to a -4, okay? So there's a couple of things I need to look at here. The first thing is we are crossing over from a positive shear to a negative shear, so somewhere along this line our shear equals 0. And it's important to note that when shear equals 0, our moment is either reached a max or it's reached a min. So we are actually going to need to find where we have crossed this line. And you may be asking yourself, well, how do I do that? I don't know magic. I don't know what I'm doing. If I have to cross and shear equals 0, then I can set my shear equation equal to 0, and I can back calculate 4x. So I can determine here that 8 equals x squared over 3. x squared equals 24. X has to equal the square root of 24 square root. And I get 4.9 feet. So if I kind of go through here, I'm going to guess that that's like 1, 2, there's 3, 4, 5. So it's crossing over about right here. And if I can look at that, I can tell that probably I have a curve that's shaped like this. If you don't know how the shape is, plug in x equals 1. Plug in over here, x equals 1, x equals 2, x equals 3, and continue getting values of shear so you can actually plot this. But we now know that we have 0 shear at x equals 4.9. That means we're going to have a maximum or a minimum for our moment. As I move across the beam and I get to the 6 feet mark, I see that it's a constant. We are just constant right here at -4, and then magic happens and we close that graph. Okay, we started here at 0. We pushed up 8. We have a reaction. So if we're just barely past that reaction and we haven't really started this linear load, then I'm pushing up, which means my internal shear is pushing down. Okay, positive is down, so positive 8. Oh, and you couldn't see any of it. Oh, yeah, you could see that. Okay, so now we need to go on with our moment equation. So that's what we did above, except I got my work over here in the wrong spot. So here we are going from 0 to 6, and here we are going from 6 to 8, 6 to 12. So if I have a 0 for my x, my moment equals 0. If x equals 6, my moment equals 6 cubed, 9 divided by, change the sign, 48 plus 24. And I need to figure out at x equals 4.9, because I told you that was going to be a max or a min. I need to do that one as well. So I have 4.9 to the cubed, 9 divided by, change signs, 8, enter 4.9 times, plus. Moment equals, we're just going to call that 26. Okay, so indeed 26 is greater than 24. So I'm starting at 0, and I'm going to be going to 24. But I know at this point, I should get my straight edge out because I harp on you guys all the time about using a straight edge. At this point, we actually have our maximum of 26. And again, if you don't know what the curve is going to look like, you know what you can do? You can plug in a 1, and then a 2, and then a 3, and then a 4, and then a 5, and a 6. And you can actually plot out that curve. You can do it in Excel. It'd be super easy. So we have our moment from 0 to 6. Now let's work on our moment from 6 to 12. So if x equals 6, then our moment is going to be 24. If x equals 12, then our moment equals 12 negative 0. So we go from 24 to 0. Well, that's good because I started at 24. I don't have an external moment applied here, and I'm going to 0. And it's good that I'm going to 0 because guess what? I have a pin and a roller on the outside parts of my beam, and they don't carry moment. I don't have applied moment. Okay, so if you guys are kind of looking ahead, you can actually see on here that I have a 1 degree curve, and I go to a 2 degree curve, and I go to a 3 degree curve. I have nothing going on. I have a 0 degree curve, constant. I have a 1 degree curve. My equation shows that. And again, you may be saying to yourself, well, can I just integrate? No, you get to write the equations just like the rest of us, but you can check your equations that way. You just have to note that when I don't start at 0, then I'm going to have a boundary condition. I'm going to have a boundary condition. So when I integrate -4 from 6 to 8, I have to remember that I'm not starting at a 0 and I'm starting at some number. I'm actually starting at 24, and so you'd have to include your boundary conditions. But we're not doing it that way. But at least you can kind of check your answers to make sure you're on the right track. So if you're having problems with these, please, 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 you need to work through these over and over and over and over and over, and talk to a TA if you need additional help. Thanks. Bye.